Hello, this is Mr. Johnson. I'd like to take a little bit of time and introduce you to a new field of study that we will be focusing on for the rest of the semester. We will be learning what is called meteorology. By the end of this semester, I hope that we are all, on some level, amateur meteorologists. My hope is that we can study the atmosphere well enough to have a better understanding of what's going on around us and hopefully maybe even be able to understand things like weather patterns and cloud cover better than we do right now. You can see the goals listed below. My goal today is to give you a background of the atmosphere and its composition, and ultimately I'd like you to be able to identify the different layers of the atmosphere and their characteristics. After this little video, you will have a web quest that you can find on Classroom. Also, the information contained in this video will be on tests and quizzes that you might see in the future, so I'd like you to be aware of that so you can be ready. It's not a bad idea to take notes, either on paper if you'd like, or on your Chromebook, so you can pause the video now if you'd like to make that happen. All right, so let's get started. I'd like to give you a little bit of background before we dive fully into this. A little bit about the atmosphere. For a long time, ancient Greek philosophers and humans in general thought that the air was actually one of four fundamental elements. This was their understanding of the atmosphere. So they thought fire, air, earth, and water were those four elements, and if they were combined, those four elements, into the correct proportions, they would make everything on Earth. It was the thought. An example of that, not dealing with the air or whatnot. An interesting example of that is a Greek philosopher by the name of Thales, who thought that plants were made of water, because clearly if I add water to the ground, the plant gets bigger, so obviously the plant must be made of water. Now, we know that there's a little bit more that goes into that now, but with time and knowledge, we experience some growth. So the atmosphere. We think of it as being air. It's really air with material in it of different characteristics, I guess. Or I guess the air in the atmosphere, depending on where you are, has some pretty different characteristics. It's actually made of gases, dust, particles, liquid water droplets, ice crystals, all sorts of stuff going on up there. But really, when it comes down to the atmosphere, is the area of air that surrounds the Earth and extends all the way up into outer space. And we'll talk a little bit more later. And we have talked somewhat about what is the difference between our atmosphere and outer space. And as it turns out, it's sort of one blends into the other, and we'll discuss that later. Let's start with the gases in our atmosphere. To begin with, there are two kinds, or two general ideas. There's gases that are permanent and gases that can change quite a bit, are variable. So the gases that are permanent, they remain pretty consistent, pretty constant in their amounts. And so if we think of just the permanent gases, 78% of those permanent gases is nitrogen. So if we were to breathe in, about 78% of that breath is nitrogen. And for reasons that we are not going to get into in this class, not a lot of living things can use nitrogen. So when you breathe that in and breathe it back out, all of that nitrogen would come back out as well. What else did you breathe in? Well, about 21% was oxygen and about 1% was argon. And if you do the math quick, 99% of the permanent gases would be nitrogen and oxygen. So we're pretty much breathing in mostly those two, which is pretty great because a lot of organisms used to, a long, long time ago after the Earth formed, just when the living things were starting to develop, oxygen was pretty toxic. And so it's a good thing that we can survive on it since there's such large amounts of it in our atmosphere. From there, let's look at the variable gases. Variable means that they change due to the time, place, and conditions that we're discussing. The two most variable, the two types of gases that are variable in the highest quantities would be carbon dioxide and water vapor. Now, carbon dioxide, give or take, I've listed it down there. It's 0.03% of the variable gases would be carbon dioxide, or I guess, 0.03% of all of the gases would be carbon dioxide. And then water vapor varies quite a bit for reasons that I'll bring up in a minute. And then everything else combined is about 0.01%. So we're talking about a very small amount of all of the rest of the gases that make up our atmosphere. Added together is 0.01, very small. To focus in on the variable gases, just water vapor, it can vary anywhere between 0 up to 4%. Now, it varies because of all sorts of different characteristics, ranging from what season it is. We even within each season, we know that still sometimes in the summer and sometimes in the winter, it can be more humid or less humid. It also has to do a little bit with altitude. Biomes is an interesting one. For example, if we have more plant life, like in the Amazon rainforest, there is more release of water from those plants. It tends to be more humid, and so that's why we call it a rainforest, because higher humidity usually equals higher amounts of rainfall. So that's why water vapor is variable. It's because, if you have more of it in liquid form on the ground and less of it in the air, it tends to evaporate. If you have more water vapor in the air than you do on the ground, well, it tends to condense and fall to the earth. Well, I guess comparing the earth to the sky in that situation, that second example wasn't the best. But the basic idea is if there's a lot of water vapor in the air, it's going to condense and it's going to fall to the earth. So it can vary quite a bit. Carbon dioxide, if we have a little bit of time later, hopefully we'll be able to get into carbon dioxide. The basic idea behind that is carbon dioxide cycles between the biosphere, living things, the atmosphere, air, and the geosphere, basically the earth itself. And so the carbon dioxide, though it tends to vary at a slower pace than water vapor. But it does cycle between things like the atmosphere. It can be stored in the oceans for quite some time. Living things like plants will take up that carbon dioxide and store it in its body. It can be stuck in rocks. All sorts of different things can happen with that carbon dioxide. The current level and 150-year ago level is listed below, and you can see that it's growing, and it doesn't look like much. When we talk about numbers that are that small of a percent, it doesn't seem like much. But as it turns out, it doesn't take much for there to be a difference between the warmest time on Earth and an ice age. So again, like I said, hopefully we'll dive into that, but we're not going to right this minute. Why is it increasing? Well, the overwhelming majority of scientists point to humans burning fossil fuels, constructing buildings, using vehicles, our use of electricity, and even to some extent, how we've actually changed our landscape, with farming and other agricultural practices. But again, I'm borderline diving into that right now, and I'm not going to. We will hopefully later. The last variable gas that we'll talk about is ozone, O3. This oxygen, or this molecule made up of 3 oxygen atoms, is very important to us. It protects us from UV radiation. UV radiation is what we're attempting to protect ourselves from when we put on sunscreen, like I didn't do this last weekend when I decided to go kayaking and got my first sunburn of the year. Well, that UV radiation, it can damage life. It can damage your very cells. And ozone is this nice layer in our atmosphere. Actually can be found all different places, and we'll talk more about the different kinds of atmospheric ozone versus. We'll talk about the different kinds of ozone layer. But what we need to know right now is that ozone in the right place is really good. It is a nice protection from those harmful rays. Now, over the last decades, these things called CFCs were released into the atmosphere by, you guessed it, humans. And the CFCs, what they do is they basically take that O3 molecule and they break it apart so it can't do its job anymore. And what that does then is, you can imagine, it would increase all of the it would increase the effects of that UV radiation. So we have damage to crops. We have higher rates of skin cancer. We have higher rates of eye issues going on. And so that hole in the ozone, that thinning of the ozone, has been repairing itself very slowly. But again, even ozone, since it's variable, can be affected by things besides humans as well. Again, that's one of those things that we will attempt to look at later, hopefully if we have time, when it comes to taking a little bit of our year that's left to look at pollution in our atmosphere. Let's shift our focus from gases to particles. Particles we can loosely classify as just any sort of small suspended material. It could range from dust to salt and sometimes ice. And it can also consist of microorganisms like fungi and bacteria. I didn't list viruses on there, although they are particles as well, but they are not organisms since viruses are not alive. But they would be considered to be in that grouping as well. As we go through the semester, we will see what's oftentimes labeled as ppm. That stands for parts per million. Now, this is how we measure the amount of particles and other gases in our atmosphere. Essentially, what that's saying is if we were to go into a particular area of the atmosphere that we're interested in, if we were to somehow capture and measure 1 million particles in that area, how many of them would be carbon dioxide? Or how many of them would be, dust? So when a scientist says that there is 350 parts per million CO2, or, I guess they'd probably say the concentration of CO2 is 350 parts per million, what they're saying is in that area, wherever they're talking, of 1 million particles of air, 350 of those particles would be CO2. So that's what that means. Now, in just a minute, you will be going to Google Classroom and starting a Layers of the Atmosphere web quest. The layers of the atmosphere, they vary. I guess they're characterized by how much they are different from each other in terms of temperature and the composition of the air. So as you go through the web quest, really focus on the different similarities, but mostly the differences of the layers of the atmosphere. I will be doing another lesson like this to go through those different layers after you have gone through the web quest. But for now, I'm going to stop the video and let you get started on that. Thanks for listening.